We're going to evaluate the integral of inverse secant of square root of x. Now we'll use integration by parts, but first we need to make a substitution. Let y be square root of x, then squaring both sides, y squared is x, and so 2y dy is going to be dx. Now let's return to the original integral and replace all the x's with y's. This is inverse secant of square root of x, which is now y, and dx is 2y dy. So we're going to use integration by parts. We'll call this integral, we're evaluating the integral of u dv. We need to make a selection. Clearly, it's much better to let u equal to inverse secant of y, because it's easier to differentiate inverse secant of y than integrate it, and that dv would be 2y dy. So from here, you need to remember the derivative of inverse secant. Derivative of inverse secant of y is 1 divided by y times the square root of y squared minus 1 dy, and an antiderivative of 2y, we can take that to be y squared without adding any constant. So our original integral was the integral of u dv. By integration by parts formula, that's equal to, let me write this here, this is the integral of inverse secant of y times 2y dy. That's equal to u times v, which we can write as y squared times inverse secant of y, minus the integral of v du, which is the integral of y squared divided by y times the square root of y squared minus 1 dy. Now the second integral should be easier than the first, and in this case, of course, it is. So this is equal to y squared times inverse secant of y minus the integral y squared over y is y divided by the square root of y squared minus 1 dy. So what we have to do is evaluate the second integral, and it's done easily by substitution. So let's do that here on the side and then come back to the problem. So we want to evaluate the integral of y divided by the square root of y squared minus 1. Let's make the substitution. Let w be y squared minus 1, so that dw equals to 2y dy, and 1/2 dw equals to y dy. Substituting that into this integral, we see that in the numerator y dy, that's 1/2 dw, and in the denominator square root of y squared minus 1 is square root of w, which we can write as 1/2 outside, w to the minus 1/2 dw, and this is 1/2, and this will be w to the 1/2 divided by 1/2, so that 1/2's cancel, and we get square root of w, which is in the original variable the square root of y squared minus 1. So now we return to the problem. We had the integral of inverse secant of y times 2y dy was y squared times inverse secant of y minus the integral of y divided by square root of y squared minus 1, which we evaluated that just now. That's minus square root of y squared minus 1. And now the last step, recall that we had y equals to the square root of x, and our final answer then is as follows. The integral that we wanted to evaluate, the integral of inverse secant of square root of x, is equal to y squared, that's x, times inverse secant of y, which is inverse secant of square root of x, minus square root of y squared, which is again x, minus 1, and we add c, the constant of integration, for the final answer. For more